Okay. Hello, everyone. Thank you, everyone, for joining our webinar session today. As you all know, today's session will be focusing on Karamba 3D and interaction on ShapeDiver. We've been working with ShapeDiver for a couple of months now, and we would like to use this webinar to present some of the new features and the developments from our side on Karamba 3D, but also on ShapeDiver's side. My name is Matthew Tam, and I'll be moderating along with a colleague of mine. Today we have in the webinar session Clemens Presinger, who's the founder and developer behind Karamba 3D. And we also have Pavol Knapo from ShapeDiver. So Pavol is a architect. He has BIM expertise, and he's working in the professional field for around 11 years, and he's been currently working at ShapeDiver, working very intensively with the sort of development in the AEC sort of industry. And so he's also the go-to guy when you're looking into developing scripts for the architecture and construction industry. So thank you, Pavol, for joining us in today's session.
Thank you.
And with that, I would like to give the slide over to Clemens, where he will be showing a short presentation. Later on, Pavol would then be also showing us some presentation from ShapeDiver, and then we will go through some live examples. The webinar will be recorded and will be made available on our YouTube channel, so feel free to share this with your colleagues or watch it at a later date too. If there are any questions also, please feel free to write them in the chat, and we'll try to address all these questions either during the session or at the end of the session. So thank you, and I'll put it over to you, Clemens.
Thank you, Matt, for the nice introduction. Hello, everyone. In the next few slides, I would like to show a little bit how Karamba works and how it can be set to work within the environment of ShapeDiver. Basically, Karamba is an interactive finite element toolkit, which is based on Grasshopper. As you can see here in this first slide, it can be used to set up a structural system in the environment of Grasshopper, which can then be interactively changed. And you immediately see the results if you change the part of the geometry and how the structure reacts. There are several ways of how you can assess a structure to assess its performance, how it behaves under a given set of loads. There are several optimization possibilities like cross-sectional optimization, reinforcement optimization. Then there's a evolutionary structural optimizer also available. And all of this can, of course, then also be used within ShapeDiver. Here, some examples for graphical results, where you can see the cross-sections, bending moments, shear forces of a beam. And the whole thing works in Grasshopper, but now it can also be used within ShapeDiver. Although it works a little bit differently. In ShapeDiver, you can set up the definition and change the input parameters via sliders, as you can see here in this slide, and thereby you can interactively also change the loads, the support positions, and so on. This is a project which was done at Bollinger Grohmann. It's a pylon for an electric power line, which was done by PART Architects. It's located in Risti, Estonia, and it consists of a steel pylon, which can be supported in different ways. The geometry can be changed, and according to each setting of the geometry, you get different results due to the cross-section optimization, which was in this instance here used also as a part of the design. This is how the structure looks in real life. And as I've said, Karamba in ShapeDiver works a little bit differently than in Grasshopper because some of the user interface widgets that are available in Grasshopper, like for example the sliders, radio buttons, they need to be translated into the interface components in ShapeDiver. And this is the reason why we have actually included a so-called parametric user interface for those components that include those interface widgets. As you can see here, it's with version 2.0.0 of Karamba, it's possible to drive the display of the model properties also via a pure parametric user interface. And in this way, it's easier to use in ShapeDiver. By the way, if you want, you can download this version 2 as a work in progress version from Karamba Nightly Builds from GitHub. What we also did, actually my colleague Georg Lobe, he included in this new build components for getting a nicer graphical output of some of the support and load symbols, as you can see here on the left side. And in this way, you can make the images nicer to view in ShapeDiver. Here, an example for the beam view component, which can also be fully parameterized, and here for the shell view component. My colleague Matthew Tam, he will go through 2 live examples in the coming hour. One of those is in a design of an industrial hall, where Matthew will show you how to set up this definition and how to create an online configurator out of it. And the second example showcases a structure which was initially done by instructors at the University of Virginia. And my colleague Georg Lobe, he adapted the script, and it's an example for the possibility that you can upload a geometry as a DXF file and analyze it using ShapeDiver and Karamba 3D. So this was it from my side. I would like to hand over to Pavol now. So I'll stop sharing my screen now. Pavol, it's yours.
Yeah, thank you very much. I'm sharing my screen now. Yeah, does this work? Can you see my first slide?
Yes.
Okay, great. Okay, so without further ado, hello everyone. My name is Pavol. I'm head of design at ShapeDiver, where we are currently busy working on new platform upgrades, which we'll be rolling out in following months. Before ShapeDiver, I worked as an architect on various projects. The most interesting ones were Olympic Stadium and Tottenham Hotspur Stadium in London, where I developed parametric models for the envelopes and worked closely with structural engineers. Back then, we sent a lot of emails with Excel spreadsheets and scripts here and there. A lot of things changed since, and you can collaborate in better, more efficient way with Karamba and ShapeDiver, which we will show today. I will give you a quick introduction to ShapeDiver, to the company, a technology overview. Of course, I will also mention the pricing structure, and there will be also a live demo, which is the most exciting part of my presentation. What is ShapeDiver? It is a platform for building of any type of online application based on your Grasshopper file. Any application, any script you build in a Grasshopper, you can publish now in ShapeDiver, and publish it with everyone in the world, so people can use it simply by using a web browser. A little bit of a history behind ShapeDiver. ShapeDiver was established 4 years ago by the team from former Evolute. Matthias, Mathieu, and Alex, who developed a plugin for optimization of double curved facade. So anyone who dealt with this with optimization of panels knows this plugin. So over these years, we already have a growing number of users, 5,000 and counting, across whole globe, across multiple industries, from jewelry, design, furniture, and now we're getting more and more users from architectural and engineering world. When it comes to technology, ShapeDiver, what is ShapeDiver? So yeah, we use scalable server infrastructure to host a system that runs multiple versions of licenses of Rhino 3D, which can allow remote access at scale of all Grasshopper files using web browser. People often ask us what's the difference between ShapeDiver and Rhino Compute, for example. Rhino Compute is a great technology for processing geometry. It's a geometry calculator which you can deploy on a server or locally. And ShapeDiver is also geometry processor, but on top of this provides a space for hosting where you can host your files. And the scalable infrastructure is the important bit, which allows you to publish your models to thousands of users globally. We don't use Rhino Compute at this point because when ShapeDiver started, there was no Rhino Compute, but it's something we definitely consider and probably will use moving ahead. The way ShapeDiver works is that you download the free plugin from Food for Rhino, you install it and include it in your Grasshopper, and then you can build ShapeDiver ready model, if you like, and upload it to the platform where your users can play with the model, consume the content, mostly via the web browser. We also experimenting with the VR and AR, and also we are developing desktop clients. We will roll out first one, which will be for Rhino soon, where you will be able to access any app on the ShapeDiver from the Rhino and rev it later. So when it comes to accounts, we of course offer a free account, which I would everyone encourage to open and try, because it also comes with the Karamba 3D trial, which gives you 20 beams and 50 shells to play with, and which is enough to test the system and see the benefits which Karamba and ShapeDiver can provide to your project. Free account comes with the free Grasshopper plugin, and also we support a growing number of third-party plugins. We give you 5 seconds of computation time for free, which is enough to really start your project going. And you can share your project publicly. And of course, this comes with free forum support where me or anyone from our team can help you with any issues you have. With Pro account, you can upload bigger or larger definitions. We give you more space. You can work with more complex models, and also the computation time is increased up to 30 seconds. And you can also embed or share your models with iframe to your online shop or your company website, if you like. And of course, there's enterprise account, which provides maximum flexibility. It can be private system. You can set up custom specifications. You can develop custom plugins, choose location anywhere in the world. And this account is also required for the full Karamba license. If you are interested in licensing and in using Karamba on ShapeDiver, please go to our website, www.shapediver.com. and just click the Contact Us button, where our sales team will be able and happy to help you and give you more information about licensing and details, how you can use ShapeDiver and Karamba in your company. So let's have a look on a couple of models. Starting with first model from Stephanie Bant, who is a PhD student at Department of Architectural Engineering at Penn State University. And she developed quite clever application on top of this ShapeDiver model for collaboration between architects and engineers. So the model is basic structure, basic stadium structure, where you can change a couple of parameters, you can play with the design, you can customize it, and work collaboratively with other project partners. And she also created this sectional view, which shows you the how much light you get on the pitch, and also the structural integrity, which is the Karamba bit in that model. So you can see these deflections, and as you can see, this design gives a lot of light on the pitch, but it's not really structurally sound. So you can go back to your sliders and keep configuring project until it really works. Then let me show you a couple of models from ABT consulting engineers from Netherlands who were testing and using ShapeDiver with Karamba for developing internal tools as an internal collaboration tools between within the company. This is a tool for design and sizing glass panels. ABT engineers have expertise in glass panels or glass in general, and they developed this tool for everyone in the company so they can use it from the early design stages and size the glass panels properly. This is a great tool for everyone who is not a Grasshopper user or doesn't have time to fiddle with Grasshopper, so they can use this tool, which gives them the thickness, all the maximum stresses, and they can specify the glass panels from early on, from the beginning of the project, which is important to keep projects on time, on the budget. Okay, another project from ABT is Windbase, which is an application for design of foundations for wind turbines. So what you can see is the floors of the foundation slab and the piles for the wind turbine. You need to imagine the wind turbine sitting on top of this. And you can set the size and diameter and various properties for this model. And what I like about it, geometrically it's fairly simple, but there's a lot of intelligence in the model, which then evaluates the quantities, the materials, the prices, and also the maximum forces, and you can all set it up really easily without any Grasshopper knowledge. If you are an engineer and you know what you need to design, then you can use this simple tool and export the model further. So there's a lot of intelligence and a lot of rules you can set with Grasshopper, Karamba, and ShapeDiver, and then you can develop internal tools for your company. Last model from ABT is model for design of storage racks, where the team really wanted to push the limits of computing in ShapeDiver in the cloud. This model has up to 10,000 members, and what you can see here, this is a section through the storage racks where you can change the number of racks, and the script or the application visualizes the forces in the foundation slab. So this gives engineers really good insight of what's happening in the foundations, and they can make really decisions quickly and evaluate design. And as I said, this works with 10,000 elements, which was really encouraging result also for us at ShapeDiver to see what kind of applications we are able to support. Now let me show you two models from ShapeDiver, which we built as we were testing the system and fine-tuning the performance. This is a model of a train station, envelope model of a train station, where this could be used for collaboration within the project team, and this allows really simple and easy interface and control over the different options of the design. So this can be really good tool also for communicating with clients, for example, who don't have Rhino or Grasshopper licenses or don't even know what Grasshopper is. All they need to know is what options or what variations of the design are we looking for, and they can test them themselves. And all of this can happen within the web browser, and within a few seconds of computation time, and where you can see the color coding of the structure depending on forces and stresses. And yeah, this model has around 3,000 elements depending on the variation, and as you can see, it really performs well, and even the viewer, the browser viewer, can manage and render this amount of structural elements really well. And let me close my presentation with this lot simpler model, where I wasn't looking for a number of elements or the structural or the limits of what we can process in the cloud and render. This is quite simple model of a still connection. We have these 3 beams or 3 columns meeting in one point, which you can then parametrically change. And here I'm showing a little bit more advanced features of ShapeDiver. We also developed features for direct interactivity in the browser, where you can also drag and drop elements in the viewer. ShapeDiver is not only limited to sliders and toggles. You can set this up with a little bit of coding, and yeah, you can create really engaging and interactive models. And this could be, for example, a product of a steel fabricator, steel manufacturer, who could have this as a standard model. And then this could be exported directly to manufacturing. This is actually interesting. A lot of our customers from the furniture and design industries developed really flexible pipelines where the ShapeDiver model is embedded in their online shop, where their customers can customize and buy. And then at the point of buying, the model is sent to 3D printers and CNC machines for fabrications, or can export PDFs with drawings, and is ready for fabrication. So ShapeDiver is a platform which covers not only the present, yeah, you can send the information to your manufacturing pipeline. And yeah, that was it. That was the last model I wanted to show you. I will hand over now to Matthew, who will show you more of the Karamba model demos.
Thank you very much for the presentation, Pavol. So what I would like to show now are 2 examples where we have created for you, and also Clemens has shown earlier today. For those of you who are wondering, you can download these live examples here. There are 2 Grasshopper files as well as a trial license if you want to test out the full features in Karamba itself. And I'm now going to jump into Rhino and Grasshopper with this definition. So this is the industrial hall definition. I want to just explain how we built this up in Grasshopper, and then how it can be uploaded into ShapeDiver for those of you who haven't not used ShapeDiver. Basically, ShapeDiver reads many different inputs from your Grasshopper files and allows you to convert basically sliders as well as different toggle items in Grasshopper as different inputs in the user interface of ShapeDiver. In this example, we have a industrial hall, which is simply created by a rectangle object, which has a width or a controllable width and length here. The names of the sliders that I have defined here can also be imported into ShapeDiver, but of course we can also edit them once this script has been uploaded onto the ShapeDiver platform. Here I have a slider which controls the approximate spacing between my columns. Of course, we do not know the exact spacing because I want to have a regular spacing. That's why I named it approximate, because it divides the entire length of our hall with the ideal spacing or the optimal spacing that we would like to have. Then we are able to have set the height as well as the number of beam spans that span between each column division here. So what I have done in the script is that from this rectangle, we divide this based on this approximate column spacing here using the divide surface, which then I use to create our columns, which you can see here. Everything that's found in this black sort of group is what we use to describe our geometry setup. And so here then we have the beams of the structure, the main beams, and then the secondary beams here. One thing to note about when working with ShapeDiver is how we optimize script for performance on the web, because of course you have to imagine that if we have a very, very complex definition with many, many elements, we have to optimize it for its performance as much as possible. So in this case, there are a couple of ways of how we can apply a load, for example. And what I've done is to apply it rather than as a mesh load, which takes a slightly a bit more computational time, to apply them as line loads. And as I wanted them to define them as line loads, which have a regular, consistent line load in the middle base rather than on the edge base, and that's why I've split these into different lists here. Within our definition, I've set up a method where we can toggle between the standard beam grid or a truss sort of roof structure. And so this is basically, this first one is the setup for the beam grid. And the second setup is basically taking these beams that we generated before and creating a truss from this. If you zoom in, these are now split into different layers or different branches so that we can define separate element IDs later on. When we scroll a bit more into the, before we assemble or take these line elements into beam elements, we have to make sure that these elements are split. Karamba, we have this line-line intersection component, which basically takes any line inputs. Here we flatten them and we basically split all of the intersecting elements together. By using a little bit of Grasshopper magic, we're able then to remap this tree into our original tree, so that we're making sure that we have 5 branches as we had before, or 4 branches, sorry. And it's similar with the setup here below, that I have the different elements or different components of our truss arranged into different branches where we can specify the different unique IDs, as well as then for our truss elements set, for example, our diagonal elements to be false inventing in this case. I've grafted the inputs for the ID so that each branch has a unique ID. And then we are also looking at applying cross sections. So now if I scroll under to look at our cross sections, in this case, we're applying a cross section optimization based on the input that we originally set up. I'm looking at HEA profiles, so standard EU I-beams. For the cross-section optimization, we need to first specify a starting cross-section, in this case, the HEA 100. And this is applied to both setups here. So the regular beam grid as well as the truss here. So that's the cross-sections. For our roof structure, or for the columns itself, we want to define joints between our columns and the beams themselves. So that's why I have here, for our column elements, we specified that at the ends of our columns, basically where it touches the beams, we are releasing them in the rotational axis. For defining my loads and optimization process, I'm defining element sets. So where A2 and A1 refer to, for example, my secondary beams in this here, A1 and A2, I'm grouping them together later on. So for our cross-section optimization, we can optimize it as one group. For our setup, for our loads, for our supports, I'm just taking the starting point of our supports. Here you might see that my component reads old, and this is because I'm using now the work in progress 2.00 version of Karamba, whereas this script has been written with the 1.3, so everyone can open it in the old setup, but you see the setup still works. Lastly, we need to define our loads. As I said, I split the beams into A1 and A2, where I calculated the load. Here I have a mesh load of 2 kilonewtons per square meter, and I distribute them accordingly onto my beam elements with these two equations. So here in the end, if I look into my output, I have 7.14 kilonewtons per meter on our A2 elements and 3.57 kilonewtons per meter on our A1 elements. And we're also applying gravity in our setup. And of course, this is a setup that you can increase the load, which will also influence our results. Lastly, before I assemble the model, I have this value list component here to basically switch between the typologies of either beam and truss. And this is also a very useful component because we can use, this is also read in our ShapeDiver interface. So for example, if I now select truss, using the stream gate filter, I can either say if I want to have the truss geometry or the beam geometry. So once feeding all the information from this model, we can then do the optimization. In our setup, I'm optimizing all of the members, but basically using them as a group optimization. So therefore, I'm using all these element IDs that I've specified here, meaning that all our beams A1 and A2, which have been set in a group element set A, will be optimized as one profile, as you see in our render view right now. This is the list of 24 HA profiles that we have. And then we already see the results from the optimization, the mass and the maximum displacement of this setup. And lastly, with every Karamba setup, we want to visualize the results. Here I've created a component to view the results using the model view. I've disabled the deformation so that we're only seeing the basically the real shape, and I've activated the beam view, which shows you the rendering of the model. And so here you can see that the utilization of a model is set to 100%, and you can see the rendering of the utilization on the elements themselves. So blue representing tension, red representing compression. In this component here, we want to extract the utilization of the elements as a numerical value. Based on Eurocode 3, so taking into consideration buckling, for example, in the calculation of the utilization, and here we can see the maximum utilization of the elements. And the last point is to render out a list of results onto a text tag, as you see here. So here I've just created a list of numbers or values, the area, the column spacing, the total weight, the maximum displacement, and the maximum utilization as a percentage. And so if I was to now either change the setup, of course, you would have the varying values adapt to the setup, and then you can go back and change the slider values to match. To upload this into ShapeDiver, I'm going to open now my browser. And it's a very, very simple setup. We have to simply go to your account. Once you've logged in, I'm going to go to upload. And I'm going to take the script that I've saved. For those of you who do not have a full license, you can basically simply set the values of the sliders to be less than 20 elements so that you can actually analyze this in ShapeDiver. If we were to now just drop and drag our definition here, it's going to upload. We can give it a title, industrial hall, for example. You can give some information about the model. We just have to click next. And then I'm going to keep it private for now. So it's uploaded into my private account. I want to review it before I publish it, of course. It's going to take a little bit of time just to upload and process the model. Oops. It seems, sorry, I think I've uploaded the wrong example there. Let me just upload this one. So if we upload, this is the one which I saved, which has the trial license. So hopefully it should only have now less than 20 elements. So once it's processed, you'll see now the setup. This is one which has only, I think, 18 elements, I believe, something like that. But of course, you can increase the sliders. This is still the sort of the background where you can still control the setup. Here we have all the sliders that we have. Here, for example, you can double click and change an input here. So, for example, if you want to render the beam or the truss version, if you want to move the sliders around, you can also do this. And you can also deactivate specific sliders or inputs too by clicking here. And then we can say, okay. And then basically the settings will be applied. And then you have your model basically ready to be hosted on ShapeDiver. So with this is a very, very simple way to upload your script to ShapeDiver. I want to show now the second setup, which is this analyze custom structure. Oops, so now our renderings of our normal forces are very, very high. So I'm just going to go back and scale them down here so that we can go and preview the script. So this is also made available in the package. And this time we're using these unique ShapeDiver components, which allow you to upload your geometries, or basically, in this case, a DXF file into your into the ShapeDiver platform. And then we have set up a definition that reads from this DXF file, and then you can create a Karamba setup. As you all probably know, Karamba is built for, is the default setting for Karamba is meters. So your file should be set into meters. Here we have if I double click on this link, we have uploaded this to a Dropbox folder where it's linked. So basically this is the default file, which is linked. But you can also control, you can upload your own files, but you need to set a default path for it to set for when you upload your script. This is then read into this geometry input component from ShapeDiver. And here we're inputting, or we're basically extracting from the DXF file curves, or in our case, lines, points for our supports, and meshes, which are going to be used for our loads. So our curves, our points, and our lines. And we're using the clean tree just to simply remove any of these null elements, which are non-curve elements like you see here. We do this explode to explode all the segments if you have joined polylines, for example, and then I have the line intersection here to basically explode all the elements. I just realized I'm a bit short on time, so I'm just going to show a bit quickly. It's the same setup. We have the line to beam. We have, in this case, circular hollow sections for the cross section, and we're also doing an optimization. So here's taking one cross section. The supports are taken from the DXF file and defined as supports, and then the loads are defined as a mesh load here with this slider value here, and also gravity. The models are assembled together, and we're once again performing an optimized cross section. In this case, I'm rendering out 3 different types of results with this mesh view here. I have a slider for the model view. So if I want to preview the just the deformation using the slider here. The second one is if I'm showing the normal forces, which I can also scale here. And the third one is the bending moments. The reason why I've split it into 3 segments is that it's not currently possible to show the deformation scale in the beam view, or the beam view in the normal forces and the bending moments output, because this slider, as Clemens mentioned, is basically a factor multiplier. So if I was to extract the section forces from this component, you're actually multiplying the loads in our setup. And this is why I've got 3 different setups here for the mesh output. The last part is basically showing once again, the rendering of the results. Here, oops, it's in white, so you might not be able to see it so well. But the results are rendered out with the tag here. And then we have the rendering of our supports. As Clemens mentioned, the model view does not allow us to currently render out the results of the meshes. So we've generated some support symbols. And then the last is also just to generate the preview of our loads using these geometry. And with the new developments in Karamba 2.0, we're hoping in the future to also give this functionality embedded already in your Karamba setup, but this is going to come in the future. So once again, you can upload this into the ShapeDiver platform. I'm not going to upload it now, but I'm going to go to our dashboard, and then you can see this definition here. And here, for example, once we upload it, we have these 4 different inputs. Here we're able to select, for example, a different XF file, for example, and I can select this file, and it will basically upload and then compute the structure, and we're going to get some information about the setup already here. And the other inputs are the standard ones that we had from Grasshopper script, the display of scales, of the load, sorry, and the deformation scale if we have the deformation here selected. So that's it for the general presentation of the definitions. Like I said, these definitions are available on this on our webinar website, and we'll also be sharing them later on also as examples, a bit more detailed. Feel free to download and play with them, and also change them so that you can use them for your own setups. And I think there are probably quite a few questions that we would like to address now. So maybe I'll stop my screen sharing and we can address some of the questions that we might have. So I'm just going to go for, so that's it for the sort of presentation stage of the today's session. As we went through quite a lot of topics today, I would like to open this discussion up to also with Pavol and Clemens. And there are a few questions that relating to the topics that we discussed today. One question maybe is to maybe more to Clemens, and I'll basically put him onto. There was a question from Vishva. Is there a project available for bridge design or any module available for analysis of bridge elements? As a bridge engineer, I always feel that there should be some tools to optimize the sections before going to details, analysis, and design. Clemens, would you have any sort of input on this?
Okay, I mean, there's no specific bridge design module, but you can do second order theory analysis if you want to work with tendons. You can simulate moving loads with this mesh load component. Yeah, that's basically it at the moment. So for steel bridges, I would say it's well possible to design to do the initial design with Karamba. And of course, we plan to add features in the future like warping, torsion, and so on. But at the moment, that's what is there: second order theory, analysis, tendons, steel beams.
Thank you, Clemens. I think there was now another question that was more relating to the ShapeDiver interaction. I believe we have answered this, but maybe I'll also bring it up with Pavol. So there are, Pavol showed this. You showed this example of the point manipulation, and I think you've already answered this. But maybe if you can give some further insight into this, yeah.
Yes, I posted few links which you can follow. There is a couple of tutorials in our documentation, and also I would like to draw your attention to a webinar we recorded last year, where we covered a lot of topics, but including also the point manipulation. There's a link to our YouTube channel. You have also a lot of resources in the description of the video, and also I share the link with the code for the model. But in essence, how this works, how to set up the model, is that you create, for example, for this steel connection detail, I created spheres as a, the grip points as a simple mesh spheres in Grasshopper. And important is to give them some understandable name, not just use the default component name. And this is important then to reference in the code where you can set up the interaction groups in the code, and this is covered in the tutorial. So you need to prepare the definition before you upload it to the ShapeDiver, and then you reference to the gripping point in your code. I shared a few examples, but if you have any questions, then feel free to contact us also on our forum, which is forum.shapediver.com, which leads to Macnil forum, and you can ask questions regarding ShapeDiver there as well.
Thanks for that, Pavol. There was a question I think we addressed quickly in the webinar session, but with regards to sliders in ShapeDiver, it is possible to, I mean, the question was, how do you define which sliders from Grasshopper you want to be visible in ShapeDiver? So I showed this example very, very quickly, but it is, of course, possible to set which sliders are visible, but by simply deactivating once you've uploaded your script to the ShapeDiver platform. Is there any additional feedback from your side, Pavol, in terms of good workflows for this?
Yes, well, at the moment, there is no other way, as you just mentioned, but the good news is we are going to publish, release plugin upgrades in coming weeks. We're already testing it, so it's really coming up soon, where you will be able to also order the position, order the sliders, so you will be able, and also with the future releases, you will be able to group parameters already in Grasshopper, which will save you some work. You don't have to deal with the sliders in ShapeDiver, but there will be both ways. You can set them up either in Grasshopper or in ShapeDiver. But you have control over which parameters you expose to your users, of course. And the same also goes to outputs.
Okay, that's great. Yeah. There was a question in regards to, we have already answered this, but can I upload any Grasshopper to Karamba definition to ShapeDiver? So Karamba is now supported with the 1.33 version on ShapeDiver. As you saw, I tried to upload a script which had some components with the 2.0 version of Karamba, and it failed. And this is because plugins need to be, for example, first activated and also confirmed on ShapeDiver's side before they are freely available to use. But everything that you can find in the 1.33 version of Karamba can be uploaded on ShapeDiver. You would need to have a license to be able to analyze more than 20 beam elements and more than 50 shell elements. But feel free to get in touch with ShapeDiver in regards to activate your license. Maybe there's a question for Karamba, which I will maybe address to Clemens. There is this question: will version 2.0 be open to working in different model units, i.e. millimeters?
Yes, it will. There will be the option that you can set the units of the physical units of the geometry via a settings component. And it will also be possible to set the results and input physical units of the components. So yes, it will be possible. It's already there in version 2 in the work in progress version, but I think there's still a bug, a small one. But basically, it will be possible. Yes.
Great. Maybe we keep a bit more to the Karamba questions at the moment. Someone asked, does Karamba take account of stability and buckling effects in the cross-section optimization component?
Yes, it does. It does so according to Eurocode 3. So you have to define a buckling length, and also it includes lateral torsional buckling, where you also have to set the corresponding buckling length. So it does take account of stability in this specific way.
Great. And I think the last question is from Vishwa again regarding to bridge design. If possible, if anyone is willing to contribute for development of any module like bridge design, of course you're free to contribute any development. Like I think Clemens mentioned at the start of the presentation, we have this GitHub page where you can download the work in progress version. You're free to also, for example, submit your bug reports as well as feature requests. But also, we are very, very open in general for collaboration with the wider community if you have specific focuses, because of course, it's not possible for us to do everything ourselves, and it's always a great opportunity for us to collaborate with anyone. So feel free to write us an email or get in touch with us, either on GitHub or by email, like I said, and we'll be open to collaborate with you. I think there are a few other ShapeDiver questions, which I'll address to Pavol now. Are there UI plugins such as Human UI or Conduit compatible with ShapeDiver?
Not the UI part. The human plugin, we support the texturing components, for example, but not the UI components. If you want to create your custom UI components, you can do it with the direct embedding of the model and with the web components with JavaScript. Or there are different libraries. With the future releases, we will also improve the how you can customize the UI for the iframe. But yeah, if you are really serious about some custom user interface of your models, it's probably good to employ web developer and building it with web technologies.
Okay, thanks for that. Another question from relating to ShapeDiver. Does ShapeDiver integrate features for collaborative work like a versioning system?
Very good question. Not just yet, but it's definitely on our roadmap, and this is something which we will develop soon. We already start prototyping and drawing wireframes. But versioning system is definitely something we are going to deliver. Yeah, probably later this year or next year. I don't want to give you any deadlines or promises when we deliver, but definitely ShapeDiver. Where we're going with ShapeDiver is that we want ShapeDiver to be the platform for publishing Grasshopper models, something like GitHub for Grasshopper, if you like, where you will be able to do the versioning, and also we will develop more collaborative features, including team management and user management, permissions, and these things. So this is coming soon.
Oh, that's great. I'm looking forward to that. I think we have a few more questions. One was from Vishnu. We have a question. Can we use environmental analysis plugins with Grasshopper and upload these models onto ShapeDiver?
To some extent, it's possible now with Ladybug and Honeybee, but we are working now on better support for these plugins because not all of the components are currently supported, and we are talking with the developers of these two plugins, and we are definitely planning to release this by summer this year, where you will be able also use ShapeDiver for publishing of environmental analysis with these two plugins, which will be a nice complement to Karamba structural engineering tools.
Okay, thank you for that. And I think let me just look in the questions quickly. I think there are two questions now relating to the Karamba input, and maybe I'll address these to Clemens then. One question is related to timber design. So is timber design something currently developed by Karamba team? So far, I'm using additional plugins to do the preliminary design based on internal forces that Karamba calculates. Clemens, are you able to offer some more insights onto this?
Yeah, I mean, it's on our roadmap, so to say. At the moment, there are plugins like Beaver, for example, where you can use Karamba output of forces to do your cross-section design. What we're currently doing is getting load and result superpositions to work, which is then necessary to do a more refined timber design. And once this is there, which will be included in version 2, then we will get more deeply into timber design procedures. So at the moment, one has to use a third-party plugin for timber design in Karamba.
Okay, and I think we have one final question at the moment. The last question so far is, are you going to create a module of concrete design with reinforcement? I think this may be relating to optimization as far as I'm understanding the question.
Mm-hmm. Yeah, I mean, for shells, there is a reinforcement design component already available. And it is a feature which will come in the future, where you can do then also cross-section design of beams for biaxial bending and compression. So it's on our roadmap, but it's not yet there for beams, but it's available for shells.
Okay, thanks a lot. I think at the moment there aren't any more questions. So if there's any sort of final questions that anyone might have, please feel free to post them. Once again, I would like to say thank you to Pavol for joining us to show us and also basically to help us develop a lot of the sort of interface between ShapeDiver and Karamba. And I think there's definitely a lot of possibilities from this side. There are actually a couple of last questions now, last minute questions. Sorry. Okay, I'll just publish them. The questions that we have are, so are we planning to implement features related to load combinations? Clemens.
Yes, this will be the next step. At the moment, I'm in the final stages of implementing the linear joints, and the next feature will then be about result and load combinations. And this is certainly a feature which I'm looking forward to, because then the possibilities of Karamba will be enhanced, I would say. So this is the next step.
I think, and there's just one question. I'm not really sure what they relate to, but someone was asking, how can you print from ShapeDiver?
You definitely can. I guess we're referring to 3D printing, but you can also export PDFs if you want to print drawings. Then yeah, we recently also released a bunch of components for compiling PDFs. But you can also export mesh. It depends on your Grasshopper application. So if your Grasshopper definition produces mesh which is clean and dense enough for 3D prints, then yes, you can share, you can export it from ShapeDiver, and link it to your manufacturing pipeline, to your 3D printers via APIs. So this is something which some of our clients did. So yes, it is possible, but it needs some further development, and our API definitely allows that.
Thanks for that, Pavol. And I believe that's it for all the questions. So once again, I would like to thank Pavol and Clemens for joining us. We're really excited to see what comes out of this collaboration with ShapeDiver, and I hope you're also willing to test and experiment a bit more with your own workflows on this platform. We are always open for any feedback regarding to your user experience with ShapeDiver, especially with Karamba. And feel free to get in touch with us and also with Pavol at ShapeDiver. I think you shared your email on your presentation, but I think you can also always give an email or shout an email to Pavol in regards to technical questions on ShapeDiver, and he would readily answer these. So thank you everyone for your attendance, and we hope to bring you some more webinars in the future, and see you next time, everyone.
Thank you. See you later.